All right, everyone, buckle up, because today
Yeah.
we are diving into time travel.
Time travel. Yeah.
It's one of those things I think we all, as humans,
Oh, yeah.
are just fascinated by.
Absolutely.
Like the idea that we could hop in a time machine
Yeah.
and go back and see the dinosaurs.
Right.
Or witness some,
Yeah.
historical event, or even go into the future and see,
Yeah.
what's in store for humanity.
You see what's coming.
See what's coming. Exactly.
Yeah.
But today what we're doing is we're going to be looking at what real science says about time travel.
That's right.
We're not talking. It's just science fiction here.
We're going to get down to the nitty gritty.
We're getting down to the nitty-gritty.
With the physics.
With some real physics.
Yeah.
And I've got a stack of research here. Some theories.
Yeah.
Some pretty mind-bending paradoxes.
It's being fun.
And we're going to try and break it all down and figure out what's really possible versus what's, purely in the realm of fiction.
Yeah.
So to get us started, when we think of time, we generally think of it in a linear way. Past, present, future.
Yeah.
It's just a straight line. Is that even remotely accurate?
Well, I mean, in our everyday lives, it seems that way, right?
It does, yeah.
The past is behind us. The future's ahead of us. But then along comes this guy named Einstein.
Einstein, yeah.
And he kind of throws a wrench in the works with his theory of
General relativity.
And he tells us that time and space are actually interwoven.
They're all connected.
They're connected into the space.
It's this four-dimensional fabric that we call
four-dimensional fabric.
Space-time.
Space-time.
Okay.
That's a big word.
It is, it sounds like. Very science fiction-y.
It does sound very sci-fi.
But it's a real thing.
But it's a very real thing.
So how do we even begin to wrap our heads around space-time?
Well, one way to think about it is to imagine space-time like a giant trampoline.
Okay.
Right? And you put like a bowling ball in the middle of that trampoline. It's going to create a dip.
Okay.
That dip, that's gravity. That's what gravity is. It's this warping of space-time.
I see.
And the crazy thing is that warping affects time itself.
So time isn't this constant floating thing.
It's relative.
Are you saying that? Like someone living near a black hole?
Let's say you have someone living on a planet, orbiting a black hole, and someone living here on Earth. Time would actually move slower for the person near the black hole.
Wow.
They would age slower.
That is wild.
Yeah.
That is absolutely wild. Okay, so we've talked about space-time. We've talked about gravity and how that warps time. I'm also seeing some stuff in here about these things called wormholes.
Wormholes.
Which sound very intriguing.
Yeah, they're like little tunnels through space-time.
Tunnels through space-time.
Yeah.
What are those all about?
So imagine you've got a piece of paper and you fold it in half.
Okay.
And you punch a hole through it. You've created a shortcut between two distant points on that piece of paper. That's kind of what a wormhole is like.
What's a shortcut through space-time?
It's a shortcut through space-time.
So does that mean that we could potentially use a wormhole to travel through time?
Well, if one end of that wormhole was near something supermassive, like a black hole, time would move differently at each end.
I see.
And theoretically, you could create a time difference that would allow you to travel through time.
So theoretically, wormholes could be like time machines.
They could be, yeah.
But I'm guessing there's a catch.
There's always a catch. The amount of energy that you would need to create and stabilize a wormhole is just mind-boggling. We are talking about energy scales that are just beyond our current comprehension.
No. Wormhole vacations are not in our near future.
Not in our near future, no.
No time travel vacations, right? So wormholes are out of the picture for now.
For now, yeah.
But let's talk a little bit about quantum mechanics.
Oh, yeah.
I'm seeing a lot of information here about how quantum mechanics could potentially play a role in time travel.
That's where things get really strange. Yeah, quantum mechanics is all about the really small stuff. It's the subatomic world. And it operates by very different rules than the world that we see every day.
So, in the quantum world, is there anything that suggests that time travel could be possible?
Well, there are these things called closed time-like curves.
Closed time-like curves?
Those are CTCs for short.
CTCs?
Yeah, they sound a little intimidating.
They do sound kind of intimidating.
You imagine a racetrack.
Okay.
A loop where you end up back where you started. That's kind of what a CTC is.
It's a loop in time.
It's a loop in time.
Theoretically, you can travel along this loop and end up back
Yeah.
in your own past.
That's the idea.
But then wouldn't we run into all sorts of paradoxes?
The paradoxes.
Like the classic grandfather paradox.
Right, the one where you go back and accidentally kill your own grandfather.
Oh, yeah.
Preventing your own birth.
Exactly.
Yeah, those are a bit of a head scratcher.
So how does quantum mechanics try to resolve those paradoxes?
Well, one idea is that every time you make a decision, reality splits.
Splits?
Yeah, creating a new universe.
The new universe.
So there are infinite parallel universes.
Whoa.
Each one representing a different outcome.
So every decision I make creates a new universe.
Potentially, yeah.
It's a lot of universes.
It's a lot of universes.
Wow.
Yeah, this is where quantum mechanics really gets wild.
It does.
Yeah, so if you went back in time and changed something, you wouldn't be changing your own past. You'd be creating a whole new timeline.
I see.
A whole new branch of reality.
Yeah, there are other possible explanations.
Well, another idea is that even if you tried to go back and change something, reality itself would shift to prevent any paradoxes.
So it was self-correct?
Kind of, yeah, like time is protecting itself.
Protecting itself from paradoxes.
Yeah.
Wow.
Yeah.
We've got parallel universes. We've got reality self-correcting to avoid paradoxes. And I also see in the research here something called quantum entanglement.
Yeah.
And Taluna.
I think Einstein called that spooky action. Spooky action at a distance.
At a distance.
Yeah, he wasn't a big fan of it.
But what's all that about?
It's this weird thing where you can have two particles that are linked, no matter how far apart they are.
Okay.
And when you remember one, the other one instantly knows.
Instantly.
Yeah, it's like, whoop. They're communicating faster than the speed of light.
Wow.
Which shouldn't be possible.
Could entanglement somehow harnessed to manipulate time?
Well, there's this experiment called the delayed choice quantum eraser, and it suggests that actions in the future can influence events in the past.
Whoa!
Yeah.
It's wild.
So we're kind of dipping our toes into some
very strange territory.
Very strange territory.
Okay, so after all of this,
yeah,
is there any chance that you and I will ever be able to time travel?
I hate to break it to you, but probably not.
Probably not.
I mean, the energy requirements, the technology, we're just not there yet.
So no time travel vacations?
No.
No going back and fixing past mistakes?
Not yet, at least.
Not yet.
Who knows what the future holds?
Who knows what the future holds? Well, I think. This has been an incredible deep dive.
It's been a fun one.
It has. We went from, very basic understanding of time as a straight line
to this.
Warped space-time. Wormholes. Parallel universes. I mean, we've covered a lot of ground.
Yeah, we've been all over the place.
So to leave everyone with something to think about.
Yeah.
If time travel were possible, what kind of ethical dilemmas would that raise?
That's a great question.
If we could change the past, should we? Would that be a good thing or a bad thing?
It's something to ponder for sure.
It is. It's something to ponder. And, maybe someday time travel will be as commonplace as, driving a car.
Maybe someday.
But for now, it remains one of the biggest mysteries of the universe.
Absolutely.